YouTube. In my last video, we worked on a process for rewriting quadratic functions in this ax squared plus bx plus c form into what we call standard form or vertex form, where we have f of x is equal to a times some x minus h quantity squared plus k. The idea with completing the square, recall, is this: to take something in this trinomial form and rewrite it so that it has a squared binomial in it. Okay, so let's recall something here very quickly. If we had x squared plus bx plus c, and a is equal to 1 here on purpose, we could rewrite this as a perfect square trinomial if and only if this is true. If c is equal to b over 2 squared, then it factors 2, and we would say x plus b over 2 squared. So essentially, if this is true about this trinomial in the first place, if you could take half of the b term, half the middle term, and square it, and you get c, then we could rewrite this as this right here, where it would be x plus b over 2 times x plus b over 2, or just x plus b over 2 squared, which is this right here. It's a perfect square binomial, or a square of a binomial. So what we want to do in this video is look at what happens when we have an a value that is not equal to specifically 1. So let's go ahead and work with our completing the square process. Step number one was this. Let's boot the constant term, okay? When we say boot the constant term, the first thing we're going to do is send this constant term to the other side. So instead of writing f of x, I'm going to write y. But we would get this here. We would say y minus 7 is equal to 2x squared plus 8x. Now, here's the deal. In the last video, I was able to say, well, what we need to do is find a value for c here, this value that I want so that it does factor into a perfect square of a binomial, that is equal to half of our middle term times itself, or half our middle term squared. Thing is, that only works if your a value is 1. Since we have an a value that is not 1 here, what we're going to need to do is this. You're going to need to factor out that 2 so that you do have a 1 in front of the x squared. So step number 2 is this: factor out the a value on the right side. So what that'll look like is this. We have y minus 7 is equal to 2 times 1x squared plus 4x, and I will put a little blank here to denote this will be a c value. So again, this rule works over here. We could say that if this c value is half the middle term squared, then it will factor into this form. But we had to make this have a 1 in front first. So that's why we always factor out whatever a is in the first place. So now if I said, well, what I really want to have in this last spot here for my constant, we say half the middle term squared, where half of our middle term is a positive 2 and positive 2 squared is a 4. And again, what we need to do is we need to add, I suppose, add a times c to both sides. Well, let's do this. Not to both sides, but also to the left-hand side, supposing you have it set up as I do. The idea here is this. The moment you add something to the right side, remember, we have to add the same thing to the left side. It's just that I get a lot of students that want to just write a 4 here, when in reality, if I were to say, well, did we add 4 to the right side? And they're like, yes. I say, well, what if we redistribute this 2? Technically, we'd get our 2x squared back, and we'd get our 8x back, but what would you also get here? You would get 8. So we've technically added 8 to the right side, so I'll suggest this. Where you put this plus 4 on the left, I'm going to say you add a times that c value there to the left side also. So we have to add 8 to both sides. So now what I'm going to do is this. I'm going to rewrite. Okay. So the left-hand side, we have 8 plus y minus 7. And our positive 8 and negative 7 combined like terms out to be a 1 here. So we get y plus 1. And then on the right side, when we factor this, the nice thing about it is it has to factor into this form. You've caused this to happen by making this trinomial with an a value of 1 have a c value that's half the middle term squared. So we say, well, what does it factor into? Well, it's always x plus whatever half the middle term is, okay? And half of our 4 here is 2, so we're going to say this is a positive 2. So our last step will just be to boot the constant back over. So I could say step 4 essentially is isolate the y value, or f of x. I'm taking f, the y value. And we would get this. We would get y equals, we'd have 2x plus 2 squared minus 1. So let's talk about what we know from this. We could say, well, what are our h and k values here? We have a, h, and k. Our a value is 2 right there. our h value is backwards than what it appears to be as -2, and our k value here is -1. So if we said, well, where is the vertex located? Knowing that the vertex is located at hk, then we can say the vertex is left 2 down 1. That's what we see as a transformation here, shift left 2 down 1 from the parent. And then we say the axis of symmetry. What is the equation of the axis of symmetry? Well, it has to pass through this vertex and have the same x value as the x value on our vertex. So we would say that x equals -2 is this axis of symmetry. So let's say I want to go sketch the graph of this now. It just means that we're going to start left 2 and down 1. So here's our vertex value. And because a is positive here in this case, it's a +2. I know it opens upward. I'll label it kind of underneath and off to the side here, but we get -2, -1. And our axis of symmetry runs through this here and has the equation x equals -2. Okay? But as far as our a value here goes, we say a is 2. So we're going to have vertical stretch. So instead of going up 1, right 1, we're going to go up double what we normally do with a quadratic parent function. So I'm going to go up 2, right 1, which means that the point 1, 1 must be on this graph. And because this is a parabola and has symmetry, we know that it go up to left 1, and this point here, this would be -3, still 1. We would say here's the graph of our function. So last but not least, we say classifying the domain and range. The domain of this graph, just like all quadratic functions of x, will be -infinity to infinity, and it seems from observation here we cover all y values starting down at -1 and going up for good here. So we'd say the range here is starting at -1 and proceeding up to infinity. Cheers.